It's very unstable. It's about to explode. No, it's not about to explode, but it's close. The thing is, it could happen tomorrow, or it could even happen during this broadcast, and when it does, it will shine like a second sun in the sky. Recently, the James Webb telescope spotted a sudden 250% increase in the brightness of Betelgeuse, the red star located at the shoulder of the Orion constellation. This peculiar behavior has sparked excitement for a rare celestial spectacle. Some suggest that this surge in brightness might indicate Betelgeuse is gearing up to go supernova, but the exact timing remains uncertain. Experts speculate it could happen soon. Join us as we explore the depths of space and unravel the mysteries surrounding this celestial giant. Betelgeuse has the potential to reshape our understanding of the universe. Despite its name not being widely known, you've likely admired its brilliance. A radiant reddish dot shining brightly at the shoulder of Orion, a well-known constellation. Betelgeuse's enormity is staggering. If placed at the heart of our solar system, its outer surface would extend beyond Jupiter's orbit. This colossal star, easily observable, continues to captivate us. Unlike most stars, Betelgeuse visibly changes over time due to its proximity to our galaxy. Classified as a semi-regular variable star, its brightness fluctuates steadily, moving towards an eventual grand collapse in a supernova explosion. In recent years, Betelgeuse has become even more intriguing due to unexpected fluctuations in brightness. These fluctuations, including a significant surge on May 20, 2023, have puzzled scientists. Betelgeuse, a Twitter account dedicated to tracking Betelgeuse, reported a staggering 142% increase in brightness, followed by a more recent update indicating a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse currently ranks as the 7th brightest star in the night sky, climbing 3 places from its usual 10th position. From the southern hemisphere, Betelgeuse shines brightly in the early evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's significance. It offers a rare opportunity to witness the final stages of a massive star's life, providing invaluable insights into red giants' behavior before they explode as supernovae. When Betelgeuse eventually explodes, it could become incredibly bright for about a week, possibly casting shadows at night. This prospect has both amateur stargazers and professional astronomers eagerly anticipating the event. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Astronomers and Astronomy Club, notes the enduring fascination with Betelgeuse's brightness fluctuations, a phenomenon observed for centuries by various cultures. Currently, Betelgeuse's brightness cycle lasts around 130 days, significantly shorter than its typical 400-day cycle. These rapid changes offer astronomers a unique opportunity to study this stellar phenomenon in detail, shedding light on the final stages of a star's life. The unusual behavior of Betelgeuse began in 2019 after it forcefully ejected a portion of its outer atmosphere. These fluctuations in brightness are atypical for Betelgeuse, raising questions about whether it will explode into a supernova. According to a paper authored by Dupree and other scientists from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its usual 400-day brightness cycle. Since the Great Dimming, Betelgeuse has exhibited altered behavior in terms of its light and radial velocity. Despite its unpredictable behavior, Betelgeuse remains a massive red supergiant star undergoing the final stages of rapid evolution. When it exhausts its fuel, the core will collapse under its enormous mass, resulting in a supernova explosion that could outshine entire galaxies. The timing of this explosion is uncertain, as noted by Dr. Grower, an associate professor of astronomy at the University of Portsmouth. Predicting supernova events remains challenging, given the limited historical data and the complexities of stellar evolution. Betelgeuse is currently undergoing fusion processes, gradually progressing through various elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon in its core, a process that takes thousands of years. Eventually, it will progress to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and potentially forming a black hole or a neutron star. While some speculate about Betelgeuse's imminent explosion, historical records indicate that it has been growing redder over the past 2,000 years, suggesting it may take considerable time before it goes supernova. NASA estimates suggest Betelgeuse is not expected to explode for another 100,000 years, offering reassurance that its explosion is unlikely within our lifetimes. Despite the uncertainty, Betelgeuse's behavior continues to intrigue scientists and inspire advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to remain open to possibilities, even as we acknowledge the unlikely chance of witnessing Betelgeuse's explosion in our lifetime. Staying attentive to its changes may lead to further scientific breakthroughs, reminding us to keep hope alive for new discoveries in the cosmos. It's crucial to understand that our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old. Theoretically, Betelgeuse may have already exploded, and we wouldn't yet be aware of it. While this possibility exists, it's far from certain. History has shown us that our expectations in astronomy can be challenged. Prior to 1987, astronomers believed only red supergiants could undergo supernovae. However, that year, a giant blue star in another galaxy exploded, surprising the scientific community. There's still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to deepen our understanding of stellar phenomena. Despite the absence of a grand explosion, Betelgeuse's current behavior is captivating. Its oscillation between dimming and flaring unveils fascinating physics. The fact that stars pulsate on human timescales is remarkable. While Betelgeuse is currently much brighter than expected based on its usual 400-day cycle, there's hope it will eventually return to this cycle, though it's currently struggling to do so. Recent observations have suggested that Betelgeuse might be in a late phase or nearing the end of the core carbon-burning process. This stage involves the conversion of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, experts predict a core collapse leading to a supernova explosion could occur within a few tens of years. However, the exact stage of Betelgeuse's evolution remains challenging to determine, and uncertainties persist. The prospect of witnessing Betelgeuse's explosion during our lifetimes is uncertain. The carbon-burning phase can last upwards of 1,000 years, and the study suggesting an imminent explosion has not yet been accepted for publication. However, contemplating the possibility of Betelgeuse going supernova is exhilarating. It would be an extraordinary event, visible even during the day for weeks. When the moment arrives, the initial signs of the supernova's arrival will be subtle yet unmistakable, with neutrinos sweeping over Earth as high-energy photons escape from the expanding cloud of stellar debris. Betelgeuse will gradually grow brighter in the night sky, potentially reaching peak brightness 10,000 to 100,000 times its normal brilliance within just 1 week. This spectacle will astound anyone fortunate enough to witness it, marking a momentous event in astronomical history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, concentrated into a single point of light. Astonishingly, this luminosity would be visible during daylight, casting dramatic shadows at night. Predictions suggest it could be anywhere from 15 to 250 times brighter than Venus, currently the second brightest object in the night sky. The spectacle of Betelgeuse's explosion would linger in our view for approximately 100 days, captivating astronomers and offering a rare opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova wouldn't pose any threat to humans, as it's still significantly far away. Binoculars and telescopes would enable us to observe the event for an extended period without harm. However, such a dramatic event wouldn't go unnoticed. Historically, supernovae were often interpreted as bad omens, and Betelgeuse's demise could elicit intriguing reactions worldwide. Astronomers believe it could even reignite widespread interest in astronomy, awakening people from their unawareness on a civilization-wide level. Betelgeuse isn't the only red supergiant in our galaxy. Others, like Eta Carinae, might burst into the sky before it does. Statistically, our Milky Way should witness a supernova roughly every 50 years, yet we haven't seen one in the last 400 years. However, we've observed remnants of past explosions, indicating that we're overdue for an extraordinary cosmic event. It's just a matter of time before the next star puts on its dazzling show for the universe to witness. Betelgeuse's history is rich with significant events, including the Great Dimming in the autumn of 2019. This unprecedented decrease in brightness puzzled astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the reason behind its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily spot Betelgeuse from their backyards, providing valuable observations for scientists. However, to gain a deeper understanding of the star and its significant changes, scientists rely on observatories like the Hubble. Betelgeuse is a massive, unstable star on the brink of a supernova explosion. Scientists continue to monitor its brightness fluctuations and behavior in anticipation of this event. While its explosion may not happen within our lifetime, the possibility of witnessing such a spectacular event keeps the excitement alive. The mystery surrounding Betelgeuse's future offers astronomers a fascinating glimpse into the final stages of stellar evolution, captivating our imaginations as we look to the stars. Betelgeuse will eventually undergo a supernova, transforming into either a neutron star or a black hole, depending on the material left behind after the explosion. However, many astrophysicists cautioned against immediately attributing the dimming of Betelgeuse to a supernova event. They suggested more ordinary phenomena, such as convective cell activity or the presence of a dust cloud, could be responsible. A team led by astrophysicist Miguel Montargis from the Paris Observatory shed light on the Great Dimming by capturing high-resolution images of Betelgeuse using the Very Large Telescope in Chile's Atacama Desert. These images, taken between January and December of 2019 and between January and March of 2020, revealed insights into the causes behind the dimming event. The team concluded that a combination of convective cell activity and the presence of a dust cloud likely contributed to the phenomenon. Detailed images clearly showed a significant dimming in the lower left portion of Betelgeuse, which remained relatively unchanged throughout the observation period. This led to the conclusion that the dimness was caused by a cloud of dust, likely originating from a massive eruption on Betelgeuse's surface. This eruption expelled an unprecedented amount of mass, far exceeding typical coronal mass ejections observed in stars like our Sun. Scientists believe this eruption may have been caused by a plume of gas bubbling up from within Betelgeuse, aided by its normal pulsation cycle. While the exact cause and mechanism remain unknown, Betelgeuse's recovery from the Great Dimming has been closely observed by scientists. Further investigation and computer simulations reveal that the decline in Betelgeuse's brightness was indeed due to a cloud of dust partially blocking its southern region. Detailed images taken before and after the dimming, along with computer simulations, supported this conclusion. Over 10,000 simulations showed that this scenario aligned best with the available data. Montargis and his team's explanation, supported by detailed observations and simulations, have provided valuable insights into the mysterious dimming of Betelgeuse.